Hi, everyone. What we're going to be working on today, and you can see the title on the screen, is we're going to be solving some equations. We're going to make a little bit of a change from just dealing with expressions that can have any number of values to it. We're going to actually start solving equations, that being, we're going to solve for the missing value of our variable. Now, this should all be background for us. So what I want you to do is I want you to go through and try to solve all 5 of these problems. I don't care about your form. I want you to go based on your instinct, based on what you've learned in the past, but I want you to get a solution for those 5 equations. Okay? Pause the video now. Okay, we're back. And so, my guess is that for a lot of us, we were maybe able to go through and solve all of these based on inspection. And if you recall, we talked about inspection being finding a pattern and just applying that pattern. So if we take a look at equation in A, that x represents some missing something. So something plus 2 gives me 5. We might be able to come pretty quickly to an x value of 3. 3 plus 2 equals 5. And if we use that method, then that would be inspection. And if we continued along that and we said, well, something subtract 4 gives me negative 6, well, what number then when we take away 4 gives us negative 6? Well, there's our negative 2. Okay, you take a look at C. C now says, well, I don't see an operation in between the 4 and the n, so I know that that means multiply. And so 4 times some number gives me negative 12. I would hope that we'd be pretty good to come in at a negative 3. D looks a little complex. I might even skip over D and go to E. Well, E, even though there's a fraction in it, I bet you a lot of us found E a little bit easier. That says A, so some number, divided by 5 equals negative 4. And so we start to think, well, what number divided by 5 gives me negative 4? And maybe we come in on a negative 20. Okay. The reason why I asked you guys to deal with these 5 equations, not just the 4 I've given solutions to, is because for a lot of us, inspection was a means for the way we solved equations in the past. And if you even take a look, like those were relatively straightforward, I hope. But when you take a look at D, inspection starts to become a little more difficult. Like maybe significantly more difficult. And when you go to tackle D, you're trying to go like, okay, so 3 times some number minus 12 gives me 16. And so you start to say like, well, 3 times some number subtract 12 gives me 16. Okay, so if I went to 3 times the number, then that 3 times the number has to give me 28. And so if I then had to, 3 times some number gives me 28, well, then that number has to be 28 thirds. And I'm going to bet that we had a lot of difficulty working through D. So if you were able to solve the other 4 relatively quickly, relatively confidently, then I think we're pretty good at going through and using inspection. I want to talk maybe about some other ways that you've gone through to solve. So I want you to draw back from your past. As you were working your way through, sometimes people are taught to move terms. And so if we recognize that to solve the equation means you have to get the x all by itself, then that means that we have to get rid of this plus 2. And so maybe we think about moving the plus 2 across an equal sign. And if something crosses the equal sign, we learn this rule that it has to change signs. So it was a plus 2 on the left, it became a minus 2 on the right, and you were able to calculate. If you thought of solving that equation that way, you are a mover. So let's do another one just to make sure. That maybe you take a look at B and you say you have to get that y all by itself, which means we have to get rid of a minus 4. How do you get rid of a minus 4? Well, if I move it across the equal sign, then it changes sign, so it becomes a plus 4. And if I have a negative 6 plus 4, there's my negative 2. So again, if you think about solving equations that way, I would classify that as being a mover. Okay, I want to try to move you away from being a mover. And I want you to maybe see why. Like if we take this 4 that's attached to that n by multiply, and if you needed to get that n all by itself, well then why don't we move that over, and since it's a positive 4, then we subtract 4. Why aren't we getting negative 16? Clearly negative 16 is not the correct answer because 4 times negative 16 does not give you negative 12. And so I would have a lot of people go, yeah, but you don't do that in this instance. That you wouldn't go through and move that over, but instead you would divide that out. And so then we would have a lot of people that would go, okay, well then I would take that n and then I would divide out my 4. And I would argue to you, but didn't a 4 across the equal sign? And if the 4 crossed the equal sign, then why didn't you change its sign? Why isn't your answer negative 12 divided by negative 4, which is 3? And you should say, well, it clearly can't be 3 because 4 times 3 does not give me a negative answer. And so if we've kind of grown up or been exposed to this as being a mover, then you end up having to remember a lot of different rules. When you do this, when you do that, and all of those rules demand recognition. So it's experience. And I might argue to us that we maybe have a better way to do that. So what I want to do is I want to walk through these same 5 problems, but maybe use a little bit of a different way to solve it. For some of you, this is your default way, and it's great that we learn that. For others, I'm going to ask you to change a little bit. So let's tackle these same 5 problems. When you take a look now, and we look back at problem A, x plus 2 equals 5, I'm going to bet that there was a lot of people that learned about equations as being a scale. You guys love my artwork. And that scale is equal or balanced because of that equal sign. And so if I was to put a 5 in one scale and an x plus 2 in the other scale, then they completely balance out. And so maybe some of us learned, well, then what we can do is we can erase operations. We can get rid of them. We can remove an operation. And so I'm going to get rid of my scale in a second, but I'm hoping that we can recognize that we have to get the x all by itself, which means we need to be able to get rid of a plus 2. And so how do you get rid of a plus 2? Well, then you minus 2. Well, if we subtract a 2 from that left side, then my scale just went out of balance. That all of a sudden became lighter. It goes up, the other side goes down. It's not equal. And so some of us then learned, well, as long as we do the same thing to both sides and subtract 2 from this side, then this side comes back up and this side balances out and we're back to an equal statement. Okay, I'm going to get rid of that lovely artwork. And now, this may have been the sort of thing that you would have had to write in the past. That you would have had an x plus 2 and your equals 5. And to get rid of that plus 2, you subtracted 2. But if you subtracted 2 on the left side, then you have to subtract a 2 on the right side. Your 2 minus 2 cancel out on this side, and you get down to an x equals 5 minus 2, and so x equals 3. On part B, we could look at that as a scale as well. You would go through and say, I have to get rid of this minus 4. So my left side was y minus 4. Well, how do I get rid of a minus 4? I need to add 4. But if I add 4 to the left side, then I need to add 4 to the right side. Now this minus 4 plus 4 cancel out. And we have a y equals negative 6 plus 4. And so y equals negative 2. Okay, I'm only going to do this one more time. And we'll play around with C. Because for a lot of us, we follow through on this pattern. And we recognize that we have a multiply by 4 on the left side. Well, we have to get rid of that times by 4, and the only way we can do that is to divide by 4. Well, if I divide the left side by 4, then I have to divide the right side by 4. Now, this 4 divided by 4 becomes 1, and my equation becomes n equals negative 12 divided by 4, and so n equals negative 3. Okay, I want you to think back to, is that the way that you learned how to solve equations? If so, then I would call you a canceling out solution person. We are reversing operations. And I maybe want to now show you what I think is your best way to solve equations. But it comes back to looking at this line and then how it looks here. Looking at what we did here and here. What did we do here to here? Well, let's look back at the original equation. You had an x plus 2 equals 5. And you notice that when you subtracted 2 from both sides, it looked like this plus 2 became a minus 2 on the other side. Look in equation B. It looks like this minus 4 became a plus 4. Look in equation C. It looks like this times by 4 became a divide by 4. And maybe what you see then is the means to deal with opposite operations. My experience tells me that opposite operations is the best way to solve equations. It's the fastest. You write down the least, which makes your equations more efficient and generally makes them easier because you don't have to write down as much. So we can keep our brain moving as we go. So I want to tackle these same 5 problems again, and I want to show you what I would love to see as your solution. Okay, so let's take a look at these same 5. So my thought is exactly the same of I need to get my variable all by itself. So that means that I have to get rid of a plus 2. Well, how do I get rid of a plus 2? I minus 2. And now you calculate. X equals 3. Okay, you take a look at B. To get the y all by itself, I have to get rid of my minus 4. Well, then that tells me that I do the opposite operation to the other side. So how do I get rid of a minus 4? I add 4. And you come in on y equals negative 2. You now take a look on C. How do I get rid of a times by 4? Then I divide by 4. Do the opposite operation to the other side. And now I can calculate, and we come in there. Now, big picture, I would love it if we never even wrote down those red lines. Because since it is a single operation, then I would expect that we should be able to do single operations in our head. So let's jump down to E, because that was still one of the more direct ones from before. My fraction line represents a divide by. So how do I get rid of divide by? I multiply. Okay, well, negative 4 times 5 gives me my negative 20, and I can skip over that red line. Yes, you're okay to write that in, but I want us to try to skip over it as soon as we can. Okay, let's jump back to the uglier question D so that we can see this one actually becomes pretty straightforward right now. Okay, I need to get that x all by itself, which means I need to get that variable term all by itself. So the first thing I need to get rid of is a minus 12. And so how do I get rid of a minus 12? I add 12. There is me doing the opposite operation to the other side. Now that my variable term is all by itself, now I need to get the variable all by itself, which means I need to get rid of that times by 3. Well, how do you get rid of a times by 3? We divide by 3, and we come right in there. So I'm hoping for us, opposite operation to the other side becomes our most effective means for solving equations. We got a little bit of theory down in terms of process, and then we're good to jump in. So let's get down a quick note. I want you to get down your notes. It's basically a 2-step process, and that will allow you to solve any equation you ever come across for the rest of your life where you can isolate a variable term. So step 1, get the variable term all by itself. So any terms that are not variables, that do not contain a variable, get rid of them. Isolate means get it by itself. Once we have the variable term all by itself, now is when we isolate for the variable. Now is when we get our variable all by itself. That 2-step process will allow you to solve every single equation you ever come across for the rest of your mathematical life, where you can put your variables into one term. So let's get some practice with it. Okay, I'm going to walk through A with you, and then I want you to fly through B as fast as you can. So job 1, we have to get our variable term all by itself. So we need to get rid of that minus 5. How do we get rid of a minus 5? We add 5. So my other side becomes 16. Jump straight to taking your 11 and adding on your 5. Fight the urge to want to write down that middle line. Now that we've got it to this point, now I have to get the variable all by itself, which means I have to get rid of that coefficient of 2. Well, how do you get rid of a times by 2? We divide by 2 and come right in on the 8. You're going to be tempted to want to write down more lines if we're unsure. And I'm telling you, risk some mistakes. Risk it. Try to go a little quicker. Okay, I want you to get down B, and then I want you to try B on your own. Okay, so pause the video now. Okay, and we're back. So the reason why I wanted to walk through a problem like B is because I can see one major mistake. So we take a look and we say, I have to get that variable term all by itself, which means I have to get rid of that positive 3. Notice it's positive because the sign out in front is positive. So how do I get rid of a plus 3? Then I need to minus 3. And negative 7 subtract 3 is negative 10. If we did that, we made the common mistake. And I want you to take a look back up in the original and look at my gold underline. For me to get my variable all by itself, or my variable term all by itself, I have to take a look at the sign of that variable term. Notice it's a negative 2y. Make sure that we don't drop off the sign of any coefficient. Now that you got to that, then you're really good. We should be able to go through and say, how do you get rid of a times by negative 2? Well, then we divide by negative 2. Negative 10 divided by negative 2 is a positive 5. Yes, there will be some people who are going to want to write this down. And it's okay if you do. But I'm hoping that we can just say a negative divided by a negative gives me a positive, and simply calculate your 10 divided by 2. Let's fight the urge to write that down. Okay, let's keep it going. So I want you to work through those 3 equations on your own. Okay, so I want you to pause the video now, give them a shot. Okay, so what I'm going to do is I'm just going to put up 3 very, very fast solutions to these problems. And then I want to go back and I want to talk about 2 of them in detail. So I would have expected to see an awful lot of the blue. So that is, our first line could have been 15 equals negative 3x, because to get rid of a negative 5 means I have to add 5 to the other side. And now I can divide out 15 divided by negative 3, negative 5. Okay, I take a look at D. To get rid of a minus 7, I need to add 7. And now to get rid of a times by 4, I need to divide by 4. Now I notice that that fraction is not fully reduced, so I need to spend one more line and reducing. The last one. Now I have a times by 3/4 in front of my A, so to get rid of my times by 3/4, I need to divide by 3/4. I used the old-fashioned division symbol because I figured more people would like that rather than having fractions within fractions. Now, to divide my fractions, I know that I have to flip and multiply. And now I can calculate, there's my 24 divided by 3, and there's my 8. So I want you to take a peek and just see, do we match up with the final solution? Okay, I want to go back and revisit 2 other problems because there's a little bit of a shortcut if you want to think of it that way. It's a way to be more efficient. And in a different one, I want to talk about risk for mistake. So let's jump back to C for a moment. As we take a look at C, one of the issues that comes up for a lot of people is that we have a negative coefficient. And so if I was to go back and just fit in one extra line in that blue solution, that line can be troubling at times. Because we know that within a fraction we can't have a negative denominator because it doesn't make sense, that if that fraction had have been like question D, where it didn't work out evenly, didn't divide evenly, then we would have to remember to apply that negative to the top for proper form. Now, in this case, we were fortunate that when we divided it out, it did divide evenly, but that negative coefficient is something that some people really like to avoid. So I'm just going to put up our old solution again, just so we can see that maybe there's a different way that you might like better. That is, I may really want to picture that variable term on the left side, because to get rid of a minus 3x, I would add 3x. Now, if I am going to bring that negative 3x to the left side, I still have that 10 there, which really didn't gain me anything. However, a lot of people will then like to do 2 actions at once. And the same time they're thinking about getting that x to the left, they're also then thinking about getting rid of that 10 to the right. And so if at the same time I can say, well, how do I get rid of a plus 10? Then I'm going to minus 10. Then a negative 5 subtract 10 is a negative 15. And now when I do divide out that 3, notice my denominator is positive. So that's just something that can speed some things up for some people and allow us to avoid a risk for mistake. We'll get down to the same thing, same number of lines, so you could argue it's just as efficient, but some people really like having a positive coefficient on their variable term. Okay, now I want to jump down to E, because I would argue to you that that blue solution is about as inefficient as you could have. I think it includes about as many lines in that solution, and I think that there is a much better way. Instead of looking at that 3/4 as a full fraction, let's look at the operations. So when you take a look at that 3/4, we have two operations in there. We have the multiply that attaches the 3/4 to the a, and we have the divide in the fraction. Well, those are just two operations. And so we can isolate our variable by doing the opposite operation to the other side. So a different way that I could tackle that would be to say, well, how about I get rid of the divide by 4 first? Well, how do I get rid of a divide by 4? I multiply by 4. And look how simplified our equation is. Now you've made it look like a line that you've had in almost every equation. How do you get rid of a times by 3? Divide by 3. And we come in right on that line. So I think a lot of people are really going to like E as their best way of solving. Okay, let's try another bunch. So take a look at those three that you have on your screen, and I want you to tackle the same thing. So I want you to work your way through and solve each of those equations. Okay, pause it now. Okay, we're back. I think some of these ones tend to be a little more straightforward, even though I would argue that we may have had some difficulty on G or H. So let's go pretty quick through a solution. I would have expected to see an awful lot of people to isolate their variable term means I have to get rid of the -3, which means I have to add 3. And as soon as we do this, this looks an awful lot like the last question. Okay, how do I get rid of my divide by 5? I multiply by 5. How do I get rid of my times by 2? I divide by 2. And if we come in on 15 halves, that is perfect. That is a fraction that is fully reduced. Please leave it in fraction form. I think it's a great instinct to leave it in fraction form rather than to try to change it to decimal. Okay, let's take a look at G. Well, something a little bit different in G. We've got this squared up here. But let's see, is it a meaningful difference? Well, to get that variable term all by itself, then I have to get rid of my -10, which means I'm going to add 10 to the other side. Okay, now I have to try to get my variable all by itself. But notice that I have two operations on the left side of that equal sign. I have a multiply and I have an exponent. Look at what is the base of that exponent. It's the x. So that x squared is really connected right now, which means we have to get rid of that coefficient first. So how do we get rid of a times by 3? We divide by 3, and if I take 75 and I divide it by 3, I get 25. Now I can get rid of my squared. And how do you get rid of your squared? We take a square root, and then we get down to the square root of 25, 5. And so if you got that solution, you're decent. We still missed something in the end, though. And you guys might remember this sort of problem popping up on your numeracy test. Be very, very careful that every time you choose to take the square root, we've got two answers. We have a plus or a -5. There is a perfect solution for G. So if you need a moment to clarify and work your way through H a little bit, then pause it now. Otherwise, we're going to keep going with our solution. So if we have some positive coefficient people, then maybe they can see that that x squared term, our variable term, has a negative coefficient. So we might want to think of it over there. Well, that's the same side as the -23, so we're going to want to get rid of that -23 as well. Well, that means that I have this line. And maybe some people really don't like doing all those operations in one go, and they might feel a little more confident to jot that down. Well, now we can clean up some stuff. And I'm hoping that we can see that by me doing this, that's a true statement. Yes, on the left side, I have 5 plus 23, which is 28. But because we generally read left to right, then I kind of like to have my variable on the left side. Now, before anybody starts to go, but wait a second, you got rid of a 4x, so it's on the other side, so it changes signs. I'm going to say, stop moving stuff. Look what that says. What's underlined in gold is equal to what's underlined in red. And notice my next line. What's underlined in red is equal to what's underlined in gold. The fact that I flipped around my equation didn't mean anything crossed an equal sign. It didn't mean that we had to move terms. I'm simply writing it so I can read my variable left to right. Feel free to do that anytime. You'll see me do that a lot as we move forward. Okay, now we can work our way through. To get rid of a times by 4, I divide by 4. And to get rid of a squared, I take the square root. I know whenever I take the square root, I get 2 answers. And I cannot calculate the root of 7 because I would need to round it off. So you're going to leave that answer as root 7 to be exact. There we go. I think I've thrown everything at you for today. So I want to leave you with one more problem. There is your last problem for today. And I think if you were able to go through and solve I, then you probably have a good amount of what we need as we move forward. So pause the video now, give it a shot. Okay, we're back. So we take a look and we notice that we've got that as our variable term. There's our 7/3 b. That means that I want to isolate that variable term, which means I have to get rid of that plus 21. When I get rid of that plus 21, I need to subtract 21, and there's my negative 27. Okay, now to get rid of my divide by 3, I need to multiply by 3. And a positive times a negative is a negative, and my 3 times 27 is 81. And now to get rid of my times by 7, I'm going to divide by 7. And we should be pretty good to know that that is fully reduced because 81 should be a number that pops up for us as being 9 times 9. And we see that there is no factor of 7 in there. Our fraction is fully reduced. There you go. So hopefully things went well today. Hopefully we were able to kind of move away from being movers within an equation and start to look at dealing with the opposite operation to the other side. Your job now is to drill in as much practice as you can to make this process that we covered as automatic as possible. Okay, jump in, play around with some practice. Good luck.